system. What that really is I go through the turbine and I peel off some after a first stage of the turbine and I send it to go do something else. In this case, it's dropping heat into something, okay? And then it comes back in and joins back up with the compressor and goes through. So basically, I'm doing two things. I'm creating some power with my turbine. At the same time, I'm dropping heat into some other industrial process or something along those lines, okay? So what I have here is I've got most of the things, and my H's are already been calculated for it. So I don't have to go through that process and look things up like this. All we'll do here is figure out what all the powers and things are, okay? The one thing you want to make sure you know is that I've got 1 kilogram per second going through this guy, okay? And then you can see 15% of that comes off here, which means right here I've got 0.15 kilograms per second going through this process, that cogeneration process, and 0.85 kilograms per second going through the rest of this. Then they meet back up here, and then I've got 1 kilogram per second going through the rest. And that's really the key to this, is keeping track of your mass flow rates. Now, to find Q in, all I really need to do is take 1 kilogram per second times, that would be H1 minus H5. And that's really it for my Q in. Okay, and that Q in then becomes 2799.4 kilowatts. Okay, and then I've got my turbine. I've got 2 stages to my turbine. Okay, so the work of my turbine now is essentially I've got 1 kilogram per second times H1 minus H2. And then remember, I peel off this 15%, leaving 85 or 0.85 kilograms per second going through the rest. So that would be 0.85 times H2 minus H3, giving me the total work through the turbine to be 656.43. Okay. Go ahead, and I'm going to jump down to the work of the pump at this point. Okay. Now through the pump here, remember they've met back up here, meaning that okay, they've met back up, and the entire flow, 1 kilogram per second, goes through the pump. So that means my mass flow rate is 1 times H5 minus H4. It's just that delta H, and that work at the pump then is 1.51 kilowatts. Okay. Now I just have 2 more heat transfers to deal with. I'll go ahead and do, this is my cogeneration that I'm calling Q load. Remember, this has the 15% going off, or the 0.15 kilograms per second. And that will be, again, this is state 2 and that's state 6. So it'll be H2 minus H6. Again, I can grab those values up here, recognizing that my mass flow rate is 0.15 kilograms per second. And I get Q load equals to 360.3 kilowatts. So again, this is the work I'm getting out. This is the heat I'm putting into some other system. Okay, so those are kind of the 2 things that I'm trying to figure out. Again, I've got Q out over here through the condenser. I can go ahead and figure that out as well. Okay, now the difference here is I've got 2 things coming in and 1 thing going out. Okay, so my inputs are 0.85, that'll be times H3, plus the 0.15 kilograms per second of H7, minus the total mass flow of H4. Okay, and again, I've got all these H values in here, just recognizing 0.85 coming in, 0.15 going in, 1 going out, which is what I have here. Each mass flow times its individual enthalpy. Then from that, I can find the Q out is then 1784.2 kilowatts. So again, typically we start by looking at these values out there given to me. And really, after you get those H values, okay, all you need to do is when you're finding your works and heats is just keep track of what the mass flow is. It's still delta H on all of these. It's just, through here's 1, through here's 1, through here's 0.85. Okay, this one's a little bit different because I've got 2 inputs and 1 output. Right, this is 0.15 going through this one, and this is 1 going through the pump. So once I have those H's, I can easily calculate those works and heat.